During the first half of the 20th century, the Soviet Navy underwent a dramatic transformation. From the remnants of the Imperial Russian fleet emerged a force determined to modernize, experiment, and compete with the world's major navies. Yet the ambition often exceeded the experience and resources available. Many Soviet ships of the interwar and early Cold War periods reflected this gap between vision and capability. Ships that were bold on paper, but deeply flawed in practice. Some were built too quickly, others relied on untested concepts or outdated machinery, and many suffered from the harsh realities of limited technical expertise and industrial strain. These vessels were ambitious undertakings that revealed both the ingenuity and inexperience of Soviet shipbuilding in its formative decades. They stood as testaments to a navy learning by trial and error, sometimes spectacularly so. Today we're going to look at a few of these designs, the ships that never quite lived up to their expectations placed upon them. They weren't failures in courage or effort, but in execution. Ships that remind us how difficult it can be to build up a modern fleet from the ground up. The Soviet Navy/Imperial Russian Navy is something we've discussed on this channel at length. From their eccentric torpedo battleship ideas to massive battleship carrier hybrids, or their completed battleships like the Ganget or Empress Maria classes, and their shortcomings. It's safe to say Russian and especially Soviet ship construction was lacking, and I think no better class illustrates this than the Leningrad/Minsk class of Soviet destroyer flotilla leaders. In today's video, we'll discuss the problems with this class of ships, especially the weakness of their construction. Before we get into the details of their design and construction, I think it's important to discuss the quality of Soviet ship construction and the lack thereof, especially in this, the first real class of combat ships built following the revolution. In Warships of the Soviet Fleet, 1939 to 1945, Volume 1, Major Combatants, these fine gentlemen discuss this subject, and they open with this. The creation of a warship, like most sophisticated engineering products, is a process requiring balance, cooperation, and exchange of information between all participants in the process. The most important actors in this process are the naval authority, in effect the purchaser, the ship design team, designer, shipyard and suppliers of components, builder, and the Navy operator. Significantly simplifying this matter, to build one product ship, it is possible to treat the process as linear. The role of purchaser is to specify the requirements of the product. The role of designer is to prepare the design to be assembled by the builder from available components, and finally, the role of operator is to run the product. In practice, a far greater degree of information exchange and multi-directed interactions are necessary between all the actors during the whole process. They go on to describe how other navies view this exchange of ideas and material, and then they get into the first Soviet warships. The first Soviet warships were children of their time. The purchaser was experiencing a moment of great instability in Soviet war doctrine, particularly regarding the role of the Navy. It was shaped by a generation of revolutionary military commanders with little or no naval experience. Most influential was Stalin himself, forced through his ideas, unsupported by any sound knowledge, except from the brochure on naval matters prepared for him by Kirov. The party and military leaders could not accept that the law of physics applied everywhere, even in the Soviet Union, and persistently demanded ships smaller but better armed than contemporaries. From the perspective of Soviet designers, the baseline standard was not of the highest quality, as Russian naval shipbuilding generally lagged behind developments of other naval powers in the 20th century. Almost all experience was not first-rate, but due to the revolution, it was not only evaporated, but was practically annihilated. All the shipyards were nationalized and looted. Technical documentation vanished. Most of the engineering staff were mobilized or fled into the countryside to avoid starvation or emigrated to avoid persecution because of their education. They were viewed as part of the elites. The few who were left were faced with the task of implementing hugely unrealistic requirements in terms of staff and designs, given the fact that the designers were new and inexperienced. For example, Vladimir Nikitin, a former artillery officer who would direct the design of the first surface warships in 1926, graduated from the shipbuilding faculty the previous year. It also didn't help the fact that the designers also worked in what today we might call a hostile work environment. Taking from Soviet warships, the designers worked in an atmosphere of growing terror at a time of draconian punishments for trivial offenses. Industry managerial staff worked in the shadow of the Shakti trial of 1928, and all design decisions had to be made under this threatening cloud. As a result, the ships were designed in a chaotic environment characterized by contrast changes of policy and organization. From the perspective of the builders, the shipbuilding industry had to be completely rebuilt from 1927 on, after 10 years in which no new experience of ship construction had been accumulated. This was the period during which Stalin assumed absolute power in the Soviet Union, a period marked by terror, the progressive militarization of society, enforced industrialization and rearmament to which the entire economy of the Soviet Union was forced to bow to. This was done in an uncoordinated manner, with tensions and imbalances everywhere, especially in the shipbuilding arena. Coupled with these problems were technological backwardness, low cultural capital, and work ethic that had been completely destroyed by their working conditions. The ambitious production plans drawn up by Soviet leaders often fell short of their mark. Shipbuilders faced these issues and many more, and especially of actually producing their components for the ships correctly, where, for example, for the destroyer leader Minsk, her steam valve box had to be not cast once, not twice, not 3 times, but 46 times, before satisfactory results were actually achieved. These issues combined with the problems with the installation of components led to delays in their completion. An interesting report comes from a group of U.S. Navy officers headed by Rear Admiral Clarence Olson, in which they visited the destroyer Razumna at Polerny in January 1944. Commander Kemp Tolley made the following remarks about the destroyers in an intelligence report. The ship was inferior in every respect to a contemporary American vessel. Technical development is far behind that to be found in the major navies. Effectiveness in battle would be no greater than that of a World War I type U.S. destroyer. Design is not good, and there seems to be little understanding of construction measures to reduce fire hazards. Artillery was far from modern installation. I think you get the picture. In future videos, we'll dig into this a little bit more, especially in a future video on the Kirov class cruisers. I just wanted to give you all a little preview of the Leningrad class, and some of the issues they'll face in their careers. The issue with casting of the Minsk steam valve box was certainly an interesting issue, yet there were so many more with this class. I think that comes with the territory these ships came in. They were one of the first combat ships designed and built by the USSR after the end of the Civil War, and after those issues we discussed previously, it's easy to see why there were problems. Anyway, work began in 1925 with the powers that be formulating requirements, ranging from ships of a small cruiser size with 4 183mm guns to fast ships with guns of 100mm in speed adequate for a torpedo attack, at some stages carrying a seaplane. The final design, which was Design 1, was heavily influenced by the large French and Italian destroyers being built, such as the Jaguar class for France and the Capitani Romani class for the Italians, with some calling those light cruisers. Not important to our story, though. In Soviet Destroyers of World War II by Alexander Hill, he writes, "In plans of the late 1920s and early 1930s, the Uragan class or Project 2 and the older Novik class brethren of World War I vintage were to be led and supported by a series of new Soviet-manufactured destroyer or flotilla leaders. Conceived as early as 1928, the development of the Project 1 design for such vessels began in earnest in September 1930, and by February 1932, the aim was to produce vessels with a normal displacement of 2,250 tons with an impressive maximum speed of 40.5 knots. Given the lack of experience of Soviet industry in the construction of modern warships and the pressure for rapid results, this maximum speed was an ambitious goal. Not only the boilers and turbines had to be developed for the destroyer leaders, but also new armament, even if it was to be based on Tsarist-era weapons. An interesting point at the end about Tsarist-era weaponry, as well as the role of these ships being larger vessels meant to lead other destroyers or torpedo boats, a concept that is touched on in Tribals, Battles, and Darings, the genesis of the modern destroyer by the good Dr. Alexander Clark. He writes about the London Naval Treaty and its provisions for destroyer leaders. Whilst other destroyers were limited to 1,500 tons, each signatory was permitted to use 16% of their total allowed destroyer tonnage for vessels up to 1,850 tons. Theoretically, these larger ships were to act as flag vessels, the leader for each destroyer flotilla. At least that is what had been stated at the conferences which first produced the treaties. Although not an apples-to-apples comparison, I felt it was a good explanation for the role the Soviets thought these destroyers might play in their fleet. Of course, I should mention, the Soviets did not abide by the interwar naval treaties, and anytime I can quote Dr. Clark, I will. Development of the destroyers came relatively fast, with the first destroyers being laid down by 1932, these being the first series of ships, Leningrad, Moskva, and Kharkov, 2 for the Black Sea and only 1 for the Baltic. Their completion was delayed by their new armament, the 130mm 50 caliber B-13 gun, which itself had been delayed, with the main guns being fitted to Leningrad in August of 1935, while she was launched in 1933, even before the prototypes were tested on proving grounds. There were other issues with the ships which showed on their trials. Taking from Soviet warships, quality of workmanship was inferior. With poor hull construction, the hull forward later proved prone to damage in heavy weather. On trials, the ships exceeded 43 knots, but at high speeds, heavy vibration was pressed down. The propellers cavitated badly when speeds exceeded 36 knots, while at low speeds, the ships steered badly. While Hill writes, in the end, during state trials before the handover of the vessel to the Navy on November 5, 1936, the then 2,225-ton Leningrad managed an impressive 43 knots in calm waters. Impressive as the speed was, many flaws in the design and construction soon became apparent. Lifting of the bow, even with extra forward ballast, was dangerously severe. Lifting of the bow was a serious impediment to firing the main armament, and considerable vibration at high speeds, as well as the fact that the hull was too weak to allow the main guns to be all fired at once, were also major issues. The vessel was difficult to steer at cruising speeds of 30 knots and even at lower speeds, comparing unfavorably in this regard to the aged Novik-class vessels. And there were also issues with maintaining the performance of the boilers during operational use. So it's safe to say there were some issues with the first run of ships. And just so we're clear here are their particulars as found in Soviet warships, and here are their particulars as found in Alexander Hill's book. The Soviets took steps to attempt to improve the vessels, with the ships after the first series being built to an improved design with fuller stern lines, but neither design proved successful. Seakeeping was poor, and fighting capabilities were seriously reduced from a sea state of 4 and upwards, which is a moderate sea with waves between 1.2 meters and 2.5 meters. The capabilities of the ship were further reduced when the ship roll exceeded 10 degrees. The torpedo armament was useless, and the rate of fire of the main battery fell off rapidly. Another thing I should touch on is the build time of these vessels, with some of them taking up to 6 years to be completed, which is something akin to battleship construction of the French in the late 19th century, while other destroyer leaders, such as the Tribal class of Britain, taking only 2 years to complete, or the Jaguar class of France, taking a similar amount of time. But getting back to our Soviet vessels, another contributing factor was the political climate of the 1930s in the Soviet Union, with people of the Navy getting purged quite frequently, causing the issues with the vessels to be overlooked somewhat, with the Leningrad, for example, being accepted into Soviet service in December 1936, the day of the introduction of the Stalin Constitution. The chair of the Acceptance Commission described the Leningrad as ending up being very much a modern vessel, with good running and sea-keeping qualities. So much so that she sat in factory number 190 until July 1938 while they tried to work out her various defects, or at least to mitigate them. As I previously mentioned, the second series, Minsk, Archkaniki's the ex-Kiev or Kiev, and Tiflis were supposed to be improvements of the first series design, with the designers and constructors attempting to give them more reliable power systems and seakeeping qualities, with Minsk even receiving a modified bow. The changes were relatively minor and far from solving the problems of the basic design. Each of the ships were finally completed by 1940, just in time for the Soviet entry into the Second World War. The destroyers performed roles many other Soviet ships did during the war, participating in bombardments and evacuations of refugees and soldiers to safer locations as Axis forces advanced. Two of the class were lost during the war, the Moskva possibly to a Soviet submarine, and the Kirov by German air attack. The surviving destroyers, and some of the ones that were sunk, had modifications to their armaments, mainly to their anti-aircraft battery, throughout their careers and especially during the Second World War. After the war, the destroyers were used in various roles, with some being expended during missile testing in the 1960s. By the end of the 1920s, the Soviet Navy needed the construction of new cruisers, as the Imperial cruisers were certainly becoming old, even by Soviet standards. Even the Krasny Krim, as their design was a bit outdated. So the Soviets, through the efforts of the Red Navy and Italian yards, came up with Project 26 and a further evolution of that design, what eventually became the Kirov class of light cruisers, not quite heavy cruisers, as we'll soon see. Regardless, this class of ships was the largest the Soviets built during this period. Like our video on the Leningrad class flotilla leaders, there were some serious issues with the design and the construction of these vessels. In today's video, we'll go into the design and the issues this interesting class of cruisers had. Our story begins in the late 1920s with Soviet naval personnel wanting to create new ships, especially cruisers, as they couldn't compete with their existing fleet of Imperial-era ships. Those wanting to create new cruisers advocated for it in 1931 for the next Soviet 5-year plan, with a group of Baltic Works naval engineers writing a letter to the naval leadership advocating for naval capital ship construction, making the point that the development of relevant facilities and design skills was necessary for this purpose. Cruiser construction, along with other parts of the fleet, were being discussed as a part of the 1932 to 1935 5-year plan, a complex plan for the Soviet Navy intended for all 4 major fleet areas and included coastal defenses and naval aviation. 4 new cruisers were to be included in this plan. Accordingly, such a program was going to be costly, around 1.4 billion rubles, something that made the State Planning Commission and other parts of the government blush and deny the Navy these ambitious plans. Although some construction was authorized, including the reactivation of the damaged battleship Fruns, the ex-Poltava, something that didn't come to fruition. Talks continued about Soviet naval expansion throughout the 1930s, with the proposed naval plans including battleships, battlecruisers, aircraft carriers, heavy and light cruisers, destroyers, submarines, and all other manner of craft. Granted, these plans were a bit ambitious with the state of the Soviet shipbuilding industry. The more ambitious plans were not approved by the Communist Party Central Committee or by the Defense Committee, an organization that would replace the Council of Labor and Defense in early 1937. However, the Navy drafted a less ambitious plan in early 1938, including the 6 initial ships of Project 26, our Kirov-class cruisers, something that had started beforehand. There were design studies that had been taken up earlier in the decade. They were akin to battlecruisers with their size, but taking from Christopher Wright in his section in Warships International, Volume 45, Cruisers of the Soviet Navy Part 2, Project 26, and Project 26 BIS, the Kirov class. Understanding the sequence of events in the design of Project 26 is facilitated by an understanding of the evolution of the organization and responsibilities of the Navy officers and industrial management agencies involved. The Navy identified military capability goals and priorities and design features. The State Industrial Authority controlled and directed the shipyards and their associated design bureaus, which prepared construction drawings. The 2 establishments worked together to create the naval ship forces of the USSR. The 2 organizations worked hand in hand, sort of, to work out Project 26 with some hiccups in new organizations and with them foreign assistance. As we've discussed previously, the Soviet Union was not a stranger to working with foreign shipyards for help with their designs, material, construction, etc., with the Soviet battle carrier hybrid coming to mind as Gibbs & Cox, an American firm, helped to design it. For the Soviets, though, they had worked heavily with the German army and air forces throughout the 1920s and 30s, and you'd think they'd work together with the German Navy, with the Soviet Commission being allowed to tour the new Deutschland when she launched in the early 1930s. However, the Germans were less than willing to share technical knowledge with the Soviets on naval matters, so the Soviets focused their efforts on another nation whose ideology at the time would make you think that they wouldn't want to work together: Italy. Italian and Soviet relations had been quite good, starting in the 1920s, the Italian desire for Russian food products and the Soviets looking for Italian manufactured goods. Soviet ships had even made calls to Italian ports in the 1920s, with the Italians and Soviets starting to work together during these visits in the late 1920s. For our purposes, things get interesting in 1932, when again taking from right, the Italians refused to sell an existing cruiser to the Soviets, but in any case, the Soviets preferred to build the ships domestically because they could not afford to buy such a large ship from a foreign firm. Accordingly, the new Soviet Navy commander, V.M. Orlov, proposed in a letter of January 12, 1932, to the Gosplan president, K.E. Voroshilov, to order one or two new cruisers from Italy for construction in Russia, with Italian assistance. Orlov considered the Italian condottieri-type cruiser design to be the most suitable for the Russian Navy. He states that one such ship could be built in the USSR with Italian support for 14 million rubles, or two for a total of 25 million rubles. The Italians were bound to contemporary international arms limitation treaties concerning ship design and could not build ships either for themselves or for foreign customers that violated treaty provisions. So the Soviets were going to work with the Italians on these new cruisers, something akin to the destroyer leader Tashkent, and more specifically, they were going to work with the Ansaldo yard. So with this in mind, in Soviet planning to build cruisers during the second five-year plan, on April 15, 1932, the Naval Forces Chief, V.M. Orlov, approved the proposed operational tactics tasks for the new light cruisers of 6,000-ton displacement that had been forwarded by the head of the training service commander of the Navy. The ships were to perform these roles: 1. Supporting submarine operations at their bases and sea. 2. Reconnaissance support for reconnaissance and destroyer attacks. 3. Support or repel amphibious landings. 4. Taking part in combined forces attack at sea and against shore targets. 5. Combat against enemy cruisers. Throughout this time, the development of the weaponry, machinery, and other aspects of the ship were being worked out. The initial plans for 152mm guns weren't going to plan, as they were older Imperial-era weaponry, and further development was somewhat difficult. However, the development of the 180mm 7.1-inch guns were going well, and what was going to be the main battery of these cruisers, and further Soviet commissions were going to Italy to learn about the construction of these vessels and even purchase equipment, as in mid-1932, placing an order for propulsion machinery comprising of boilers and turbines capable of generating 100,000 to 125,000 shaft horsepower, and hopefully solve the issue of delays and defects in home-built turbines, i.e. those Leningrad-class turbines, and through continued talks and negotiations, the Ansaldo yard agreed to give the already constructed machinery for the future Eugenio de Savoia and further technical support for 5 years. So, for those wanting me to make it obvious, these Kirov-class cruisers, with some exceptions, followed along similar lines to Italian light cruisers, something that is evident by their hull lines and machinery, as we've discussed. However, I think Wright puts it best. Adoption of Eugenio de Savoia type machinery in a hull otherwise similar to the earlier Raimondo Montecuccoli introduced a challenge that required improvisation. Through the various changes in the design between the Ansaldo team and Soviet designers from TS-KS BS-1, there were serious discrepancies in their weight figures with additions that we'll get into in a bit. Still, for example, Kirov was 890 tons overweight on her trials, and at full load displacement, she was 636 tons overweight. Throughout the 1930s, various Soviet dockyards were allocated to build these vessels. Baltic Shipyard would build 2 ships. The first was laid down in 1935 and a second in 1936. Nikolaev was to build 4 ships, the first 2 in 1935 and the second 2 in 1936. And finally, we come to a Russian word that I simply can't pronounce. I'll put it up on screen now. A new shipyard would build the 2 for the Pacific. Granted, this was all subject to change depending on the speed of the building of the different ships, but generally they would stay in the same areas. But we'll get back to that in a second. We should probably describe the cruisers, as I'm sure that's probably what most of you are here for. As I mentioned before, the hull layout was similar to that of the Condottieri class light cruisers and similar to the Montecuccoli class, with changes to accommodate for the machinery, and the Kirovs were slightly larger forward to accommodate for the main battery, and a large superstructure along with the Russian design being slightly further aft, with a transom stern, though only having 1 large gun aft in place of 2 lighter gun turrets. The ships were primarily riveted, but were welded in non-critical structures. The ship's hulls were subdivided into 19 watertight compartments for enhanced survivability. This design was foreseen to keep the ship afloat and upright even with 3 adjacent compartments flooded, something that did prove useful. Now, the main battery was certainly interesting, and something that wasn't seen in other naval powers. A 180mm 7.1-inch weapon, something similar had been installed in the previous Russian and Soviet cruisers. However, the Kirovs would be getting the 180mm 57 caliber B1P weapons, which had slight modifications compared to the previous weapons, and there would be 9 arranged in 3 turrets, 2 forward and 1 aft. Proved to be a less than favorable arrangement for the guns. The ships had a secondary battery of 100mm guns in single turret arrangements as seen by this picture, as well as 2 triple torpedo launchers, 1 per side. Of course, they did have a smattering of different anti-aircraft guns throughout their careers, as with other ships we've discussed. For their protection, Project 26 ships had a 50mm belt, a 50mm deck, and a bridge of 150mm, and the turrets had a face thickness of 50mm. The cruisers had plenty of upgrades throughout their career, including sonar, radar, and other equipment. For some more details, I'll put up a table found in Soviet cruisers 1917 to 1945 from the October Revolution to World War II by Alexander Hill, which illustrates the details a bit better. The construction of the ships was carried out in due time. Key components for all the ships of the class were efficiently divided up by allocating orders for common items at single enterprises. While economically efficient, it caused problems creating single points of failure, where all ships might be held up by delay at one factory supporting all shipbuilding yards. Thus, all turbine reduction gears came from Kharkov, the turbine assemblies from another plant, and most of the armor from Izora, and so on. As we've talked about earlier, the cruisers were being laid down, and the ones in the Baltic, particularly the Kirov, were coming along by January 1937. We're taking from right again. In January 1937, Flagman 2nd Rank, I.M. Galler, commander of the Red Baltic Fleet, visited the cruiser Kirov under construction in the Baltic Yard and raised a question concerning the rearrangements of its conning tower and navigation bridge work, among other things. Subsequently, a senior naval staff officer, Engineer Flagman 2nd Rank, a Russian name I can't pronounce but it's up on screen now, reported to the Naval Forces Commander V.M. Orlov that the arrangements of the command facilities of the cruisers required alterations. The quadruple mast forward obscured the field of view from the conning tower aft and also restricted the coverage of the forward searchlights and 45mm semi-automatic gun batteries forward. It's safe to say the officers of the Navy had some changes they'd like to make to the ships. Construction of the first 2 ships was so far along that it was decided to continue them as they were. The decision to change the design of the latter ships was taken up in April of 1937, and thus the creation of Project 26 BIS or BIS was undertaken. The basic hull, machinery, and armament was unchanged from Project 26. Armor protection was increased in the side belt, transverse bulkheads, and on the front plates and roofs of the main battery turrets to 70mm. The number of small caliber guns, 45mm anti-aircraft guns, was increased to 9. The foremast structure was altered significantly, reduced in height, and rearranged for greater visibility. More modern fire control systems were installed, and aircraft catapults of domestic design were incorporated. Wooden furniture was replaced by metal, aluminum furniture. Normal displacement was increased to 8,882 tons, at a mean draft of 5.87 meters. There were 2 ships built to these specifications, the ones in the Black Sea, and a further 2 in the Pacific, with some adjustments to those ships as seen in the table we saw earlier. Still, I'll bring it up on screen once again, but I'll also throw in some from warships of the Soviet fleet. Up until this point, I've been avoiding saying the names of the ships because they changed quite a bit throughout their careers. However, at the start of their careers, they were Kirov, Voroshilov, Maxim Gorky, Molotov, Kalinin, and Kagnovich. We could get into their careers a bit, but let's be honest, Soviet ships didn't do a ton in the Second World War, Winter War, and Continuation War. They provided gunfire support on the coast in the Baltic and the Black Seas. The Black Sea ships Molotov and Voroshilov did more, running back and forth from Sevastopol, with Molotov having her stern blown off. Still, it was replaced by one from a Chapayev-class cruiser, Fruns, another class of ship we'll discuss at some point. And the cruisers in the Pacific didn't get up to much. During the war and post, they had many refits and upgrades and were slowly phased out, with most of them being scrapped from the late 1950s up until the 1970s. What I'm sure you'd like me to talk about at this point is what made the ships poor, and there's quite a bit. The first issue up on the list is the fact that the ships were overweight, some by quite a lot like Kirov, being close to 900 tons overweight when she was complete. They tried to deal with those issues through the use of lighter alloys like aluminum alloys for the ladders, partitions, and ventilation ducts. Despite this, she was still overweight. The ships being overweight was in part due to the large superstructures as compared to their Italian cousins in the Condottieri class. Yes, I do understand that it's not the real name of the classes, it's a historical term, so meh to Italian viewers. Along with that, the turrets being rather large and heavy due to the triple gun arrangement. All of this also reduced the stability of the ships as well as their speeds as compared to their design specifications. Something that went hand in hand with those problems was their seakeeping. Being based in the Condottieri class, they had fine lines being built for speed, with some of the Italian ships achieving 42 knots on trials, an extremely impressive feat. All of that was fine and dandy in the relative calm of the Mediterranean. However, when the Kirov ships entered service, being of a similar design, the ships had poor performance in adverse weather conditions found in northern Russia, rolling excessively, limiting their operational flexibility in the Baltic. I'm sure some of you raised an eyebrow when you were looking at the tables for their armor being so thin around the belt, especially the Project 26 cruisers. However, that goes back to their Italian heritage, as those Condottieri-class cruisers had even thinner belt armor, being 18 to 24 millimeters. The armor scheme of the Kirovs was thin, with a comparable armor scheme being the Königsberg class of Germany, and those were restricted due to the Treaty of Versailles. So with that, the cruiser's protection couldn't withstand anything bigger than destroyer-caliber weapons. Project 26 BIS was somewhat better with their 70 millimeters of armor, but overall thin compared to other ships of the period. The Project 26 cruisers also had problems with their fire control systems being underdeveloped, causing the ships to be short-ranged and inaccurate, and radar was not fitted until later in the war. As a consequence, accuracy was poor, especially at longer ranges, and reduced effectiveness against both surface and air targets. Of course, one of the most famous problems was their turrets. They were extremely cramped due to the addition of the third gun, causing the rate of fire to be sometimes as slow as 2 rounds a minute. Some sources give other numbers, but generally speaking, the rate of fire was more akin to a battleship. Granted, Major Sharp would approve of the soldiery, but when it comes to a light cruiser of the Second World War, that wasn't great. Another issue with these vessels, as with some of the other ones, relates to the inconsistency of the machinery due to issues with Soviet craftsmanship. With the machinery based on the ones found in the Eugenio de Savoia, the Soviets found difficulties in reproducing the systems to scale, with turbines and boilers prone to failure, with many of the cruisers never achieving their intended top speed. Finally, the conditions of the cruisers weren't great, as Italian designs were generally cramped and the ships were uncomfortable for the crews, with ventilation and heating being quite poor. Additionally, the aluminum furniture most likely wasn't the most comfortable either for the crews. The Soviet battleship Jean-Paul Marat, the ex-Petropavlovsk and future Petropavlovsk, started life off as a member of the Ganget-class battleships. Marat saw service throughout the First World War and interwar years, where she saw extensive refits, some better than others, and was heavily damaged in the Second World War. After she was heavily damaged, essentially being split in two and settling in 11 meters of water, she was raised and performed excellently as a floating battery. In today's video, however, we're going to look at her refits and some proposed work after the Second World War that was just so weird that I felt I needed to make a video on it. Anyway, Marat didn't start off life with that name. Instead, she was originally the Petropavlovsk, part of the 4-ship Ganget class, built for the Imperial Russian Navy in the Baltic. As we're not going to get into the development of the Ganget class, suffice it to say, with their 12 305mm guns and 4 triple turrets, a displacement of around 25,000 tons, and a top speed close to 24 knots, although they had excellent guns, they had relatively thin armor and weren't the best battleships. The battleships were originally designed to be competitive with second-generation dreadnoughts, while by the time they were being built and completed, the rest of the world had moved on to the second generation of super dreadnoughts. All of that being said, the ships were a very large leap for Russian shipbuilding. For example, they represented a far larger leap than the Lord Nelson to dreadnought in the Royal Navy, as the last Russian class built was the Andrei Przevozvany class built in 1904. However, during the Great War and the subsequent Russian Civil War, they didn't do a whole lot, at least in terms of engaging other ships. To take from Stephen McLaughlin in Russian and Soviet battleships, as the Soviet state slowly recovered from the devastation of the Civil War in the 1920s, the Sevastopol-class dreadnoughts were brought back into service one by one, with one exception, the fire-damaged Poltava. All the ships had suffered to one degree or another from neglect in the first years of the Bolshevik regime. The lack of fuel for heating proved especially serious, as it meant that the water in the pipes froze during the harsh Baltic winters, leading to leaks and bursts. During the 1920s, the ships re-entered service with minor modifications. First back in commission was the Marat, ex-Petropavlovsk. She rejoined the Baltic Fleet in 1922, and according to warships of the Soviet fleet, 1939 to 1945, she was in the best condition out of all the class. She was little changed from her wartime appearance, although she now had 6 76.2mm anti-aircraft guns, probably Lender model 1914 to 1915, 3 each on the first and fourth turrets. A new superstructure was added on top of the forward conning tower, displacing the rangefinder, which was shifted to a platform on the foremast just below the level of the top funnel. Now, Marat would ride out most of the 1920s with these changes, but the ship and her sisters were going to need some serious work if they wanted to continue having them in service with the Red Fleet. In 1925, talks about more extensive modernizations to the ships came during the drafting of the 1926 construction program, but nothing was done immediately. 2 years later, a committee headed by the Navy's Technical Administration considered modernization an urgent necessity. The fears of the committee boiled down to the ship's inadequacies of their 305mm guns, armor, engine plant, and well, almost everything about the ships really. They were old and poorly taken care of. The committee figured that to do a complete overhaul and modernization of the ships was going to cost around 40 million rubles per ship. And with trying to establish the Soviet state, famine, and other such problems, finding the money for the Navy was going to be a bit of a struggle. So, members of the Scientific Technical Committee worked out minimal and maximum conversion plans. The most serious problem faced by naval architects was the lack of blast-free above-deck space. The linear arrangements of the main battery turrets and their requisite fields of fire consumed almost all the weather deck area. Unlike most foreign ships, there was no midship section free from blast that could be utilized for anti-aircraft guns, aircraft facilities, or the like. Under the circumstances, the Soviet designers came up with the following, again taking from McLaughlin. increase the armor protection of the middle deck from 25mm to 76mm, convert the boilers to oil firing, increase boiler performance allowing for the removal of 3 boilers in the forward fire room, remove cruising turbines, install chemical protection, remove a 120mm battery, and install stronger AA battery of 100mm and 40mm guns. Install a tripod mast supporting a command rangefinder post, as well as improve gun laying mechanism, alter forward funnel to keep new bridges clear of smoke, install anti-torpedo bulges, improve seakeeping by alterations to the bow, install a catapult, and 1 or 2 new seaplanes for reconnaissance and spotting. This was dubbed the Big Modernization, and would cost more than 20 million rubles per ship, which was well beyond the economic means of the Navy. So it was decided to go with the small modernization, of which the Paris Commune, sorry I can't do the Russian version, was the first to undergo these in the late 1920s, having her superstructure, funnels, bow and other parts of the ship altered, where she was made ready to go take post as the flagship for the Black Sea Fleet, being seriously damaged in the Bay of Biscay, rolling up to 38 degrees in the storm. Next up for modernization was Marat. Taking from McLaughlin again, the Marat was the next ship to be taken in hand for modernization, and a more ambitious reconstruction was carried out. She was followed in turn by October Revolution and once again Paris Commune. Each reconstruction was based on the one before. The ship was brought to the Baltic Works for modernization in 1928. The work lasted 2.5 years, the ship re-entering service with the Baltic Fleet on April 8, 1931. The most obvious change in her reconstruction was the elaboration of the forward superstructure, which was required for the new fire control gear. At the top of the tubular tower foremast, 33.5 meters above the waterline, was the KDP-6 command rangefinder post. This featured 2 6-meter Zeiss rangefinders. This being somewhat similar to the British DCT, other platforms around the foremast and conning tower supported the control equipment for the secondary battery and searchlights. The limited space available meant that the new superstructure was relatively cramped and very close to the forward funnel. So following the Paris Commune's earlier refit, the funnel was raised 2 meters and angled back. The after superstructure was somewhat modified, but nothing to the degree of the forward part. The Soviets did order seaplanes from Germany, being carried atop the third turret. However, as there was no domestically produced catapult yet available, the aircraft would be launched and recovered from the water. The aircraft were rarely carried or used. The main guns were given a modest overhaul. The 305mm guns were replaced, along with the machinery and electrical equipment. The secondary battery was unchanged, but more anti-aircraft guns were added as well, these being Maxim machine guns and 76.2mm guns. The machinery was also improved with the addition of oil-firing Euro boilers. The greater steam productivity of oil firing made it possible to remove 3 boilers from the forward fire room, the space vacated being used for anti-aircraft ammunition stowage and other posts like damage control center, radio room, and even a hydrophone room. The changes also made it possible to make the ship more watertight, sealing hatches and doors for moving coal. The cruising turbines were also removed, which simplified the engine plant. Other alterations to the ship were made, especially in light of the Paris Commune's experience in the Bay of Biscay. But Marat was not fit with anti-torpedo bulges, eventually completing her transformation in 1931, where you might be asking yourself, all these changes seem pretty good. How could this go poorly? Well, it just will. We'll have to wait and see, though. McLaughlin writes, the Transform Marat underwent trials in 1931, at which time her metacentric height was 1.93 meters at her full load displacement of 25,890 tons, compared to the original design's 1.76 meters. The fact that her initial stability increased as a result of her modernization was probably because her fuel was now oil stored in the double bottom rather than coal in the side bunkers up in the ship. However, an unhappy discovery was made during these trials. At some speeds, the tubular mast began to vibrate, interfering with effective fire control. Increasing its rigidity would have required substantial reconstruction, so shock absorbers were fitted to the optical instruments to minimize vibrations. Various minor modifications were made to the ship throughout the coming years, Still, by the 1940s, it was clear that Marat's modernization was not satisfactory, especially compared to the October Revolution. So another reconstruction was planned, and hopefully find a way for the mast and superstructure to not vibrate so violently. Still, it would never come to fruition due to the Second World War, being sunk in September 1941, and it was never fully repaired. The conversion wasn't an outright terrible idea, certainly improvements on her condition beforehand, but that vibration was a serious problem and made using the new equipment difficult. Coupled with the fact that the Ganget class weren't the best battleships, and by the 1940s, very old, it culminated in a bad situation for the battleship. Now, I think it's appropriate to discuss her service in a limited sense, and that sinking, as it's critical to understand the future proposals. Marat and the October Revolution were stationed in the Baltic and participated to a limited extent in the Winter War, struggling to get involved due to the Finnish coastal batteries. But when the Finns had issue with their coastal batteries, the battleships could get to work, with Marat on December 19, 1939, firing 133 rounds of high explosives near Viborg, with her gunnery actually being quite good, destroying buildings and knocking down trees that concealed the Finnish guns. The Finns thought they had gotten a hit when the guns were working, but Russian publications made no mention of such a hit. But in any case, the Finnish guns were closing the range, so she got out of there. Subsequently, the battleships left the area and made their way back to the Baltic base at Tallinn. With the Germans massing on the Soviet border, Soviet naval forces were taking measures to prepare, where to take from McLaughlin, Soviet plans called for the 2 battleships plus 2 Leningrad-class destroyer leaders and 20 destroyers to operate behind the mine barrier at the entrance to the Gulf of Finland, while 2 Kirov-class cruisers and 2 flotillas of destroyers would defend the Gulf of Riga. On June 20th, 1941, Marat returned to Kronstadt, but October Revolution remained at Tallinn. Within days of the German invasion on June 22nd, Soviet defenses were crumbling, and with the rapid German advance having taken Riga so quickly, it was clear that Tallinn would soon be besieged, and the October Revolution was withdrawn. Due to that rapid advance, soon enough Axis forces were getting close to Leningrad and had effectively immobilized the 2 battleships of the Baltic Fleet with minefields laid in the first 6 months of the war. Some 21,000 mines were laid in the Baltic, and in particular the Gulf of Finland, which some historians have described the sea being polluted with mines. Not only that, operations were limited due to the lack of fuel in the city as the Germans tightened their siege. Both ships suffered damage from German field guns, but nothing that caused serious damage until September 23, 1941, when Marat was attacked by waves of dive bombers and was hit by 2 1,000-kilogram bombs, or for us who use Imperial units, 2,200 pounds, almost simultaneously. Both bombs struck in the vicinity of the forward superstructure. Immediately following was the detonation of the forward magazines. The turret was heaved up as well. The conning tower and forward funnel were blown over to starboard. 326 men were killed, including the captain and executive officer. And the forward part of the hull was, from frames 20 to 57, demolished. The after part of the ship was still left afloat. However, progressive flooding caused the ship to settle in 11 meters of water. The ship was raised and returned to service as a floating battery, an impressive feat considering the damage. She continued to take damage, but suffered nothing major after that. On May 31, 1943, she was given back her original name and continued to operate as a floating battery until the end of the siege of Leningrad. By the time the siege had been lifted in January 1944, she had fired an impressive 1,971 305mm shells. At around this point, talks were beginning about her reconstruction, considering the extensive damage to the ship. Some context to the refit of Petropavlovsk. In the Second World War, as some of you like to point out, yes, I see your comments, the battleship was on its way out. But as the Soviets, and especially the Americans, showed, older ships with heavy artillery could still play an important role in providing gunfire support to military targets in coastal areas, either to defend an area or for an amphibious assault. They were also useful as training vessels due to their size. Post-war, the Soviets possessed 2 working battleships, the October Revolution in the Baltic and the Sevastopol in the Black Sea. with special consideration being given to the Petropavlovsk to refit her with the damage in mind, that of course being the explosion in the forward main battery magazine. The first ideas of such a thing were happening in 1943, where it was proposed that the forward section of the Fruns ex Poltava would be used to replace the damaged bow of the Petropavlovsk, a simple enough idea. In addition to the new bow, the third turret was to be moved to replace the destroyed forward turret, and the space amidships thereby gained was to be used for 130mm guns and other anti-aircraft guns. An excellent idea considering what we had discussed previously about the lack of space for such weapons on the ship. Deck armor was going to be reinforced and bulges added, bringing the ship to a new displacement of 30,000 tons. This idea never really went anywhere beyond drawing boards, though. Taking from McLaughlin, a similar plan was proposed toward the end of the war when TSK-B-17, the design bureau in charge of large surface ships, was directed by the Navy Commissariat to work out a plan for restoring the Petropavlovsk to a reasonable operational condition. Once again, the destroyed forward section of the hull would be replaced with a part of the intact hull from the Fruns. In response to the assignment, TSK-B-17 came up with what might be described as a minimal reconstruction of the ship, less ambitious than the 1943 plan. With the Fruns' bow grafted on the forward section of the ship, the Petropavlovsk's operational third turret would be moved to the number 1 position. The deck space vacated between the funnel and the after superstructure would provide room for a powerful battery of 130mm guns. Elaborate superstructures would be erected fore and aft, reflecting the increasing importance of fire control and communal facilities. The tall tower mast shows a director that looks similar to the KDP-8 directors intended for the Sovietsky Soyuz and Kronstadt classes. The original secondary battery would be eliminated and casemates plated over. The new battery would be 16 130mm guns and twin turrets, where the third turret was originally mounted as seen in this graphic. It's not clear if these were the older 50 caliber guns or the newer 58 caliber guns, or if they were dual purpose or not, along with a new smattering of smaller anti-aircraft guns. The armor protection was relatively unchanged from the original arrangements, with the conning tower being increased to 195mm and the turret roofs being increased before the war to 150mm. Unlike the 1943 plan, the ship's weak horizontal protection was to not be improved, nor were anti-torpedo bulges to be fitted. As for machinery, it isn't very clear. The original publication says the boilers were to be reduced from 20 to 16, and whether these were to be new, more powerful boilers is unclear, although it is likely they would be, considering when the ship was damaged, she lost most of her forward boilers. The available drawing shows only one large funnel, so the machinery spaces would have been moved around to accommodate this new design. The ship was certainly going to be interesting in this configuration. Certainly not a match for anything on the high seas at the moment like the Iowa class, Vanguard, or any of the remaining battleships, except maybe the Julia Cesare, the future Novorossiysk, link in the description. Anyway, McLaughlin writes, "The end result of this reconstruction would not have been a battleship in the traditional meaning of the word, a ship designed to fight her counterparts on the high seas. Instead, she would have been a fairly competent, if weakly protected, gunfire support ship. Nevertheless, on October 31st, 1946, Admiral Kuznetsov recommended that the reconstruction of the Petropavlovsk be cancelled. No further work was done on the Project 27 design, although the formal cancellation did not come until June 29, 1948. On November 20th, 1950, the Petropavlovsk was renamed Volkov and used as a school ship until she was finally stricken on September 4th, 1953, and subsequently broken up. There you have it, folks, some rather interesting refits, proposed refits, and part of a career of the Petropavlovsk. Now, the final proposal, although interesting, probably wasn't the best idea, considering the way the world was going, being an easy target for aircraft in the Baltic. Nevertheless, an interesting bit of history. Thank you all so much for watching. I hope you enjoyed the video. Please remember to like and subscribe as it'll help the channel to grow, and until next time, my friends, have a great week.